Scientists claim that the universe began with an event known as the Big Bang, which occurred roughly 13.7 billion years ago. But the lingering question is, what triggered that explosion, and why did it happen? Over time, we've delved into the science and history of our universe, and the Big Bang Theory has stood as the primary explanation for the phenomena we've observed. Numerous studies and countless scientists have worked on gathering research, and the collected data consistently supports the Big Bang Theory as the principal. 29 seconds explanation for how the universe came into existence. According to this theory, dark energy, a form of energy that is even more prevalent than galactic energy, is seen as the anti-gravitational force that has been driving the universe's expansion ever since the Big Bang. Science today is vastly different from what it was in earlier times, and with advances in technology, new theories emerge. Many times, we find that what we previously thought was entirely true is not the case at all. Makaku has even proposed the formal debunking of the Big 1 minute and 2 seconds Bang Theory, partly because the James Webb Space Telescope has detected 750 new galaxies that look completely different from what scientists had expected. This discovery presents a fresh perspective, encouraging us to investigate how the James Webb Telescope is reshaping our comprehension of the entire universe. Join us on this exciting journey beyond the observable universe, and let's explore the newly discovered galaxies in greater detail. If you're keen on staying updated with the latest universe-related news, subscribe to our channel. 1 minute and 34 seconds like this video, share it to reach a broader audience, and activate notifications for new updates. The images of new galaxies taken by the James Webb Telescope are simply breathtaking. In just one picture, we can observe hundreds of galaxies, and the magnificence and grandeur of these photographs are truly remarkable. Yet, what's astonishing to researchers is actually quite different from what might surprise the average person. While these images are awe-inspiring to the scientific community, they don't align with the expectations based on the 2 minutes and 6 seconds current theories. In fact, the number of galaxies observed is much higher than anticipated, and these galaxies are unlike others in that they are smaller than expected and exhibit ages far more remarkable than imagined. These surprises are sparking a sense of alarm among scientists, with even an article beginning with the word panic in its title, underscoring the gravity of the situation. These galaxies defy everything that was predicted based on long-standing theories. For many years, scientists proposed the Big Bang Theory, 2 minutes and 37 seconds, as the central explanation for the origin of our vast universe. According to this theory, around 13.7 billion years ago, the universe originated from a mysterious cosmic event. However, the newly captured images challenge the long-accepted narrative of the universe's birth. The images from the James Webb Telescope are shaking our understanding of the universe's origins, particularly since they seem to contradict the Big Bang Theory, which has been regarded as an unquestionable fact by most cosmologists. The galaxies seen, 3 minutes and 9 seconds in these images, are surprisingly small, smooth, ancient, and far more abundant than predictions based on the Big Bang Theory had suggested. The observed galaxies are also 2 to 3 times smaller than those captured by the Hubble Space Telescope, which completely contradicts the expectations set by the expanding universe hypothesis. According to this theory, as the universe expands, objects should appear larger with increased distance. However, the galaxies observed by James Webb appear to contradict that idea. Furthermore, the smoothness of these 3 minutes and 42 seconds galaxies was not anticipated. According to the Big Bang Theory, galaxies should display irregularities and structural variations due to the dynamics of their formation and evolution. However, the images show galaxies with unusually smooth structures, lacking the level of roughness and complexity that would typically be expected for galaxies of their age. This challenges the anticipated timeline for the formation and evolution of galaxies as envisioned in the context of the Big Bang Theory. In the early universe, all matter, energy, and 4 minutes and 14 seconds, the foundational elements of the cosmos were compressed into an extremely dense point known as the singularity. At this moment, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of the singularity is rooted in our understanding of physics, particularly in Albert Einstein's general theory of relativity. Within this singularity, all the matter and energy of the universe existed in a highly concentrated form. The incredible density suggests that an immense amount of mass, 4 minutes and 45 seconds, and energy was compressed into an infinitesimally small space under immense pressure and density. In such extreme conditions, The temperature inside the singularity would surpass any imaginable or measurable temperature we can understand today. The energy within this hot, dense point was the very origin of everything in the universe as we know it. The singularity marked the start of the cosmos, from which everything emerged. After the singularity, the universe began its expansion and inflationary period. 5 minutes and 15 seconds, which occurred over approximately 13.7 billion years, ultimately giving rise to the universe as we observe it now. The expansion of the universe started with a rapid, enormous burst known as cosmic inflation. During this phase, the universe expanded far faster than the speed of light, stretching space itself and pulling everything along with it. Cosmic inflation played a pivotal role in forming the large-scale structure of the universe, smoothing out irregularities, equalizing the distribution of matter and energy, and setting the stage for the 5 minutes and 48 seconds subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of its expansion gradually slowed. It is important to note that while cosmic inflation was a brief period of rapid expansion, the universe continued expanding at a measurable rate, a process known as cosmic expansion. Scientists have studied the evidence of this expansion, including the redshift of light from distant galaxies. Redshift occurs when light waves stretch out as the universe expands, shifting them 6 minutes and 20 seconds toward the red end of the spectrum. During the expansion, all the matter that makes up the universe was compressed into an extremely small volume. It became apparent that matter could not survive in such a compressed state, so transformations took place. As the universe expanded and cooled, in this early phase, particles like protons, neutrons, and electrons began interacting with light and energy, which played a crucial role in the formation of matter in the universe. During the first minutes following the Big Bang, this process, 6 minutes and 51 seconds called nucleosynthesis, involved the creation of basic elements. Chaotic and disrupted galaxies formed by multiple collisions were expected to be observed, but the James Webb images present a different narrative. Instead of chaotic, colliding galaxies, the telescope captures well-organized, disk-like, and spiral-shaped galaxies similar to the ones we see in the present-day universe. This unexpected finding challenges the assumption that mergers are a fundamental part of galaxy evolution. If these galaxies have not undergone many, and so on, the implications of these findings extend beyond just challenging the Big Bang theory. They raise deeper questions about the fundamental forces shaping the cosmos. If the universe did not begin with a singular explosive event, then what alternative explanations exist? Could the universe be part of a continuous cycle of expansion and contraction, as some alternative models suggest? Or could we be missing an even more profound mechanism governing the evolution of space and time? 14 minutes and 20 seconds. One possibility gaining traction among some scientists is the idea that the universe did not have a definitive beginning but has instead existed in some form indefinitely. This concept, often associated with the steady-state theory or newer cyclic universe models, suggests that matter and energy may be continuously created or transformed over time, eliminating the need for a singular origin event. The unexpected smoothness and apparent age of the galaxies detected by the JWST could support such a framework, indicating that the structures we see today may have existed in a similar form for far longer than we previously assumed. 14 minutes and 55 seconds, however, not all cosmologists are ready to abandon the Big Bang theory just yet. Many argue that these findings may not contradict the theory itself, but instead indicate that our understanding of early galaxy formation is incomplete. Perhaps new physical laws or processes, not yet accounted for in current cosmological models, influenced the way galaxies formed in the early universe. Some researchers speculate that unknown interactions involving dark matter and dark energy could have accelerated galaxy evolution in ways we do not yet fully understand. 15 minutes and 30 seconds. As the scientific community debates these possibilities, researchers are eagerly awaiting future observations from the James Webb Telescope and other upcoming space missions. The planned Nancy Grace Roman Space Telescope, set to launch in the next decade, is expected to provide additional insights into cosmic expansion, dark energy, and the large-scale structure of a universe. Meanwhile, ground-based observatories, such as the Vera C. Rubin Observatory, will complement JWST's discoveries by conducting deep sky surveys that could reveal even more hidden galaxies and cosmic anomalies. 16 minutes and 5 seconds. While the quest for answers continues, one thing is clear: we are on the verge of a new era in cosmology. The discoveries made by the James Webb Space Telescope have shaken the foundations of our understanding, proving that even our most well-established theories must be open to revision in light of new evidence. This is the essence of scientific progress: challenging assumptions, refining models, and embracing the unknown. 16 minutes and 35 seconds. If our universe is far older, more complex, and more mysterious than we ever imagined, what other cosmic surprises await us? As we peer deeper into the vast expanse of space, we may one day uncover truths that redefine our place in the cosmos entirely. Until then, the James Webb Space Telescope will continue to be our window into the unknown, guiding us toward discoveries that could forever change our understanding of existence itself. The revelations from the James Webb Space Telescope, JWST, have sparked a profound sense of curiosity and urgency within the scientific community. If our existing models of the universe's formation are flawed or incomplete, what other cosmic secrets remain undiscovered? Could the JWST be on the verge of uncovering an even deeper reality, one that challenges not just the Big Bang Theory but our fundamental understanding of space, time, and matter? 17 minutes and 30 seconds. As researchers analyze the data, one of the most compelling questions arises. If the universe did not begin with the Big Bang, then how did it come to exist in its current form? Some physicists propose that the universe may have emerged from a pre-existing state, governed by unknown physical laws that transcend our current models. Others speculate that what we perceive as the beginning of the universe may simply be one phase in a vast, repeating cycle of cosmic rebirth, an idea known as the cyclic universe hypothesis. 18 minutes. This theory suggests that instead of a single explosive event, the universe undergoes infinite cycles of expansion and contraction, an eternal process where galaxies form, dissolve, and reform over trillions of years. If true, it would mean that our observable universe is just one iteration in an infinite cosmic timeline, far older than the 13.7 billion years we currently estimate. Could the smooth, ancient galaxies seen by JWST be remnants of a past cosmic era, preserved across cycles of time? 18 minutes and 35 seconds. Meanwhile, another groundbreaking idea is gaining attention: the holographic universe theory. This radical concept suggests that the three-dimensional universe we experience is actually a projection of a deeper, two-dimensional reality. If JWST's findings continue to defy expectations, could they point toward evidence that our perception of space and time is merely an illusion? Could galaxies exist in forms that we do not yet fully understand, shaped by dimensions beyond our comprehension? 19 minutes and 5 seconds. As astronomers struggle to reconcile these discoveries with existing theories, one thing is certain: our understanding of the cosmos is more incomplete than ever before. The James Webb Space Telescope has proven to be more than just an instrument of observation. It is a catalyst for transformation, forcing scientists to rethink the very fabric of reality itself. 19 minutes and 35 seconds. In the coming years, new missions will build upon JWST's groundbreaking work. The Laser Interferometer Space Antenna, LISA, will launch in the 2030s, aiming to detect gravitational waves from some of the universe's earliest and most powerful events. If alternate theories about cosmic origins hold any truth, LISA may provide direct evidence of unknown forces at play, from primordial black holes to remnants of pre-Big Bang physics. 20 minutes and 5 seconds. Meanwhile, the search for extraterrestrial life takes on new urgency. If the universe is vastly older or structured differently than we believed, does that mean intelligent civilizations have had